you can never have too much practice dealing with the normal distribution because it's really one of those super important building blocks for the rest of statistics and really a lot of your life. So what I've done here is I've taken some sample problems. This is from ck12.org's open source flexbook, their AP Statistics flexbook, and I've taken the problems from their normal distribution chapter. So you could go to their site and actually look up these same problems. So this first problem: which of the following data sets is most likely to be normally distributed? For the other choices, explain why you believe they would not follow a normal distribution. So let's see, choice A. So this is my beliefs come into play. So this is unusual in the math context. It's more of a what do I think? It's kind of an essay question. So let's see what they have here. A, the hand span measured from the tip of the thumb to the tip of the extended fifth finger. So I think they're talking about, let me see if I can draw a hand. So if that's the index finger, and then you got the middle finger, and then you got your ring finger, and then you got your pinky. And the hand will look something like that. I think they're talking about this distance, from the tip of the thumb to the tip of the extended fifth finger, which is a fancy way of saying the pinky, I think. They're talking about that distance right there. And they're saying, if I were to measure it of a random sample of high school seniors, what would it look like? Well, how far this is a combination of genetics and environmental factors, maybe how much milk you drank or, how much you hung from your pinky from a bar while you were growing up. So I would think that it is, a sum of a huge number of random processes. So I would guess that it is roughly normally distributed. If I look at my own hand, and my hand I don't think has grown much since I was a high school senior. It looks like, I don't know, it looks like roughly 9 inches or so. I play guitar. Maybe that helped me stretch my hand. But if that's, it's really an essay question. So I just have to say what I feel. So I would guess that the distribution would look something like this. I don't know. I've never done this. But, maybe it has a mean of 8 inches or 9 inches. And it's distributed something like this. It's distributed something like this. So maybe it probably does look like a normal distribution, but it probably won't be a perfect. In fact, I can guarantee you it won't be a perfect normal distribution because one, no one can have negative length of that span. This distance can never be negative, so they're going to have a I guess you can have no hand, so that would maybe be counted as 0. But the distribution wouldn't go into the negative domain, so it wouldn't be a perfect normal distribution on the left-hand side. It would really just end here at 0. And even on the right-hand side, there are some physically impossible hand lengths. No one can have a hand that's larger than the height of Earth's atmosphere, or an astronomical unit. You would start touching the sun. There's some point at which it is physically impossible to get to. And in a true normal distribution, if I were to flip a bunch of coins, there's some very, very small probability that I could get a million heads in a row. It's almost 0, but there's some probability. But in the case of hand spans, there's no way out here. The probability of a human being who happens to be a high school senior having a, I don't know, 1 mile length hand span, that's 0. So it's not going to be a perfect normal distribution at the outliers or as we get further and further away from the mean. But I think it'll be a pretty good, in our everyday world, as good as we're going to get approximation. The normal distribution is going to be a pretty good approximation for the distribution that we see. I guess one thing that it's fun. This is high school seniors. When I did this, it was kind of from my point of view as a guy, and I would argue that high school seniors, guys probably have larger hands than women, so it's possible that you actually have a bimodal distribution. So instead of having it like this, it's possible that the distribution looks like this. That you have one peak for guys, maybe at 8 inches, and then maybe another peak for women at I don't know, at 7 inches, and then the distribution falls off like that. So it's also possible it could be bimodal. But in general, this is going to a normal distribution is going to be a pretty good approximation for part A of this problem. Let's see what part B, what they're asking us to describe. The annual salaries of all employees of a large shipping company. So if we're talking about annual salaries, we have minimum wage laws, whatnot. So I would guess that any corporation, if we're talking about full-time workers at least, there's going to be some minimum salary that people have. So I would say, and probably a lot of people will have that minimum salary because it'll be probably the most labor-intensive jobs. And you probably have most people are down there at the low end of the pay scale. And then you have your different middle-level managers and whatnot. And then you probably have this big gap. And then you probably have your your true executives, maybe your CEO or whatnot, with if this mean right here is maybe $40,000 a year, and this is probably 80,000 where some of the mid-level managers lie, but this out here, this will probably be actually, if you were to draw a real, the way I've scaled it right now, this would be 80. This would be about 200,000, which is actually a reasonable salary for a CEO. But the reality is that this actually might get pushed way out from there. It might look something like that. It might be way off the charts. Let's say the CEO made $5 million in a year because he cashed in a bunch of options or something. So it'd be way over here, and maybe it's the CEO and a couple of other people, the CFO or the founders. So my guess is it definitely wouldn't be a normal distribution, and it definitely would have a second. It would be bimodal. You would have another peak over here for senior management, up at the unless we're well, they're not saying if we're maybe in Europe, this would probably be closer to the left, but it won't be a perfect normal distribution, and you're not going to have any values below a certain threshold, below that kind of minimum wage level. So I would call this, when you have a tail that goes more to the right than to the left, call this a right skewed distribution. Right skewed distribution. And since it has two humps right here, one there and one there, we could also say it's bimodal. I mean, it depends on what kind of company this is, but that would be my guess of a lot of large shipping companies' salaries. Let's look at choice C, or problem part C. The annual salaries of a random sample of 50 CEOs of major companies, 25 women and 25 men. The fact that they wrote this here, I think they maybe are implying that maybe men and women, the gender gap has not been closed fully, and there is some discrepancy. So if it was just purely 50 CEOs of major companies, I would say it's probably close to a normal distribution. It's probably something like, well, once again, there's going to be some level below which no CEO is willing to work for, although I've heard of some cases where they work for free, but they're really getting paid in other ways. If you include all of those things, there's probably some base salary that all CEOs make at least that much, and then it goes up to some value, the highest probability value, and then it probably has a long tail to the right. And this is if there were no gender gap. So this would just be a purely right skewed distribution where you have a long tail to the right. Now, if you assume that there's some gender gap, then you might have two humps here, which would be a bimodal distribution. So if you assume there's some gender gap, this is part C right here, then maybe there's one hump for women, and if you assume that women earn less than men, then another hump for men. And there are 25 of each, so there wouldn't be necessarily more men than women. And then it would skew all the way off to the right. And in fact, I think there would probably be a chance that you have this other notion here where you have these, super CEOs or mega CEOs who make millions, while most CEOs probably just make, just, I'll put it in quotation marks, a few $100,000, while there's a small subset that are way off, many standard deviations to the right. So it could even be a trimodal distribution here. So that's choice C. And so far, choice A looks like the best candidate for a pure, or the closest to being a normal distribution. Let's see what D is. The dates of 100 pennies taken from a cash drawer in a convenience store. 100 pennies. So that's actually an interesting experiment. But I would guess, and once again, this is really a question where I get to express my feelings about these things. As long as your answer is reasonable, I would say that it is right. Most pennies are newer pennies because they go out of commission, they get traded out, they get worn out as they age, they get lost, or they get put, pressed at the little tourist place into those little souvenir things. I'm not even sure if that's legal, if you can do that to money legally. But so my guess is that if you were to plot it, you would have a ton of pennies that are, within the last few years. So the dates of 100 pennies, not their age. So the dates. So if we're sitting here in 2000, so if this is 2010, I would guess that right now you're not going to find any 2010 pennies, but you're probably going to find a ton of 2009 pennies, and then it probably just goes down from there. And of course, you're not going to find pennies that are older than say the United States, or before they even started printing pennies. So it's obviously this tail isn't going to go to the left forever. But my guess is you're going to have a left skewed distribution. Left skewed, where you have the bulk of the distribution on the right, but the tail goes off to the left. That's why it's called a left skewed distribution. Sometimes this is called a negatively skewed skewed distribution. And similarly, this right skewed distribution could all, or this right skewed distribution, sometimes it's called positively skewed. And if you have only one hump, you don't have a multimodal distribution like this. In a left skewed distribution, your mean is going to be to the left of your median. So in this case, maybe your median might be someplace over here. But since you have this long tail to the left, your mean might be someplace over here. And likewise, in this distribution, your median, your middle value, might be someplace like this. But because it's right skewed, and for the most part only has one big hump, this hump won't change things too much because it's small, your mean is going to be to the right of it. So that's another reason why it's called a right skewed or positively skewed distribution. So to answer the question, these are my feelings about all of them, but I would say, for the other choices, explain why you believe they would not follow. Well, they said which of the following data sets is most likely to be normally distributed. Well, I would say choice A, but it's really, a matter of opinion, at least in this question.